Hello and welcome to this video that I'll be explaining C program to find the roots of a quadratic equation. My name is Eugene Heise and I'm going to be taking you through a C program that is going to be calculating the roots of this quadratic equation in the form a squared ax squared plus bx plus c equals to 0. And the question says your program should be able to handle real and complex roots. So if you had see our requirements, for input handling, we want to prompt the user to enter the coefficients a, b, and c, and also validate to ensure that the value of a should not be 0. Then our code should also be able to calculate the discriminant, which is going to be b squared minus 4ac. And depending on the value of the discriminant, it should determine whether the roots are real and distinct, real and equal, or complex. And so the output is if the roots are real, that either they are distinct or equal, you should display the roots themselves. Otherwise, if they are not real, then you should just display text complex. So let's head into our code and see how this looks. So now I've created a file called quad.c, and this is where we shall be writing our code here. So first of all, before doing anything, I first import two libraries here that we are going to use for our C program. The first library that we have, or what we call header files, because they have a class extension .h. The first one is stdio, which is going to help in our input and output functionality in our code, and then the math.h, which is going to help with some mathematical calculations, as we are going to see. So what we want to do is to write a code that is going to calculate roots of a quadratic equation, the basic quadratic equation. So as you can see here in line 27, you can see this is how our equation looks like. This is the equation of the quadratic equation based on what they call a bulldozer formula. So it is negative b plus or equal plus or minus the square root of the discriminant, all that divided by 2 times a. So the reason why I'm going to be using square root is got from this math library that's going to help us find the square root easily. So based on our question that we saw earlier, they say that depending on the value, it should determine whether the roots are real and distinct, real and equal, or complex. So we have three conditions here. And so the conditions we have is if the discriminant is greater than 0, then they are real and distinct. If the discriminant is less than 0, then it is complex. Or if the discriminant is exactly equal to 0, then they are real and equal, meaning it's one root. So this is what we shall do. We shall first declare our function. As you can see, after writing our header files, we shall declare our function, which is going to be of the data type void, and we're going to call our function calculate roots, and it has parameters a, b, and c, all of the integer data type. And then we have declared it, function declaration. So before getting into our main, we are going to explain how this function works. So we are going to recall our function here, and then inside the block of code, we are going to first determine to state our discriminant of an integer type. So our discriminant in this case, our discriminant is going to be of this formula, b squared minus 4ac. So I've typed it in the way that b times b, which is the same as b squared minus 4 times a times c, and that's going to be our discriminant. Then we shall head into our if loops, that if our discriminant is greater than 0, then based on this equation, remember there are going to be two roots because of the plus or minus. However, in C, we haven't yet found a way of doing this plus or minus function. So we are going to create two roots, one to cater for the plus and one to cater for the minus. Since the discriminant is greater than 0, meaning they are real and distinct, they are not equal roots. So one root is going to be, we are going to call it root 1, and we are going to give it a double data type. And since we are giving it a double data type, we are going to also give this 2.0, not instead of calling it 2, we are going to call it 2.0 to cater for the double. So our root 1 will cater for the plus, and our root 2 will cater for the minus. And we are using square root, which we are getting from our header library math.h. So after stating these two, we are going to print f, and we're going to state that the roots are real and distinct, and then we shall later on state the root 1 with 4 decimal places, root 1, and root 2 with the same number of decimal places, root 2. Then in our else if the discriminant is exactly equal to 0, meaning the roots are equal. So meaning we shall have a discriminant of 0, so there's no need of getting the square root. So we shall just have negative b divided by 2.0 times a. And then we shall print a statement, roots are real and equal. And then we shall just state the root giving 4 decimal places. Or else, the last else statement, we are going to just print complex roots. So meaning that if it doesn't satisfy these two conditions, then it is highly likely that it's going to satisfy the last condition, that the discriminant is less than 0. So we can't state those roots, but instead we shall just give a statement complex roots. And so we are going to run our code and see how this works. So we are going to open our command prompt, and since it's a seed program, we have to first compile the code, and then we shall be able to run it and see the results. So let's head on to that and see how it works. So let me first go to the library, Gene documents. Yes. Yeah, so now I'm entering the directory of my C program file. As you can see, it's under Gene documents and under Gene C documents, and as you can see, it is here. So to compile our code, we have to first type the compiler, which in my case I'm using is GCC, and then we are going to state the name of the file, which in my case is quad.c. Then we shall say -o, and then we shall state a letter or a word. Let me just say quad, anything that you may like, quad, and then we shall press enter. If there are any errors, it will tell us in this step that there are some errors to fix. Otherwise, I don't expect there to be any errors. So what I've basically done is what we call compiling the code. So in C, we don't have functionality that comes of compiling unless you get a compiler. Since it's a structured language, it requires a compiler. So we're waiting for it to finish compiling. Yes, it has finished. So after now it has finished compiling, now we can run the code. This last quad that we had written shall now type quad.exe. So when you type that and press enter, now it's going to run the code. Or else if you don't want to write that, you can say full stop backslash then quad. It will still run. So when I click that, it is now running, and it is now giving me the prompts. Enter the coefficient a, as you can see here. So I'm going to base on this formula here, x squared plus 6x minus 5 equal to 0. So based on this, our a is 1, our b is 6, and our c is -5. So when you replace here in the discriminant, it's supposed to give us a value greater than 0, which is 56. So let's test the theory. Our coefficient of a is 1, our coefficient of b, which is going to be 6, and our coefficient of c, which is going to be -5. And since you can see the discriminant is greater than 0, we expect it to be real and distinct, meaning the root 1 is 0.7417, root 2 is -6.6417. And this is because I had set it to 4 decimal places. Yes, and that's a summary of how my code runs. Thank you for listening.